Welcome back, my dear students. Welcome back. You're all welcome, beta. Very, very happy good evening to all of you, beta. Shiva, Tarun, Kiada, Shushmit Nandi, Ayush, and all. Mehna, very happy good evening, beta. Please tell me, everyone, audio, video, crystal clear to all of you. Can we proceed? Crystal clear, sir. Okay. So now we are in lecture number 19, Reversible and Complex Reaction Kinetics, Part 2. As you all know, this side Gaurav Srivastava sir from Engineers Institute of India, India's best chemical engineering institute for GATE 2026 preparation. I had 14 plus years of teaching experience as GATE Chemical Engineering author, educator, multiple GATE top ranks like GATE 2025 AIR 43. And I'm going to start today's class with last problem of our previous class. Okay, so again I'm going to solve this question, beta, but now in a different manner, because as I told you earlier that for the same given problem you have multiple paths, beta, and during examination you have to choose the best path. Okay, like here again, if I want to write that rate of disappearance of A, then you can write like K1 Ca and minus K2 Cb. Am I correct, my dear students? Everyone please confirm me, beta. And now here you all know what we can put in place of Ca and what we can put in place of Cb. So nothing special I am going to do. Just in place of this Ra I am going to put dCa by dt, because moles are clearly constant. And here in place of Ca I can put Ca naught 1 minus Xa. And here in this Cb I can put Cb naught plus Ca naught Xa. Very, very easy. We already solved this dCa by dt in terms of conversion for epsilon equals to 0, and we got Ca naught dxa by dt, that becomes equals to K1 Ca naught, and open this bracket, beta, so it will come K1 Ca naught Xa minus open this bracket also K2 Cb naught C. Previously we assumed like something taken as a common, like Ca naught taken common and Cb naught by Ca naught assumed at just like some constant capital here. This time I'm not going to assume, just I am going to open this bracket immediately. So it can be written as K2 and now Ca not Xa. Very, very easy. Now see Xa. So again I can write this equation as K1 Ca naught minus K2 Cb naught, all constants here, and here I am taking minus Ca naught Xa common. So what will we get? I think K1 plus K2 Ca naught Xa. Now one more time, beta, everyone please tell me, is it crystal clear? Can we proceed, beta? यहाँ तक कोई डाउट नहीं किसी को? Step by step please tell me, everyone. All clear? Okay, very good, very good. So see, the same problem I am again dealing, but in different manner. Okay, that means you can also deal same equation in different manners. Okay, now here one technique is present, like just assume these all like capital A and these all as capital B. So this equation will be A minus B Xa. A minus B Xa. Now you can just integrate it. You can integrate it, and in this technique need not to show any equilibrium conversion Xa in your or Cbe in your given expression. But if we want to show, because only we can show time constant if it is the equation is in the form of XAE and XA, just as we discussed in our previous lecture. So here, my dear students, at equilibrium, if I am going to write this equation at equilibrium, so equilibrium XA will be XAE, and equilibrium means now the conversion that you obtained is not going to change, concentration that you obtained not going to change. So my dear students, here you can put in place of dxa by dt 0, okay, when xa is xa. So what we can now write in place of this expression, it's 0, and 0 becomes equals to k1 ca naught minus k2 cb naught, and minus k1 plus k2 and ca naught x a e. With the help of this expression, beta, you can write k1 ca naught minus k2 cb naught, and that becomes equals to k1 plus k2 ca naught xa. Now in place of this, now we are going to put this, and now what will happen with our last expression? Now last expression becomes ca naught dxa by dt, and that becomes equals to, in this place I can write k1 plus k2 into ca naught XAE minus K1 plus K2 CA naught XA. You can take CA naught common from right hand side, and then this CA naught will be cancelled with this CA naught. Okay. Now what will we get? dxa by dt, dxa by dt, and that becomes equals to K1 plus K2 XAE minus K1 plus K2 XA. K1 plus K2 XAE minus K1 plus K2 XA. Again, my dear students, clearly you can see, you can take K1 plus K2 common in right hand side. So now after taking this common, you can write XAE minus XA. Again, it is very good first order simple ordinary differential equation. Easily you can solve it. So for solving, I can rearrange it like dxa upon xa minus xa, and in right hand side, beta, k1 plus k2 into dt. Okay. Now we have to choose limit. So what should be our limit here? What should be our limit here? When time is 0, conversion was 0. At some time t, conversion was something like exa. So after solving, it will come ln of xa minus xa, then xa differentiation in denominator will be 0, and minus xa will be minus 1. That means here one minus will be present. So if you don't want to write that minus, so just write lower limit as upper limit and upper limit as lower limit. And in right hand side, it is k1 plus k2 t minus 0, that is t. Upper limit will give just ln of xa, lower limit will give ln of xa minus xa minus x, ln of xa minus ln of xa minus xa, and ln a minus ln b can be written as ln a by b. So here you can write now ln x a e upon xa minus xa, and that becomes equals to k1 plus k2 t. Now you can multiply with negative sign both side, so it can be now written as xa minus xa upon xa, and that becomes equals to minus k1 plus k2 t. Now taking exponential both sides, so left hand side can be written as xa minus xa upon xa, and in right hand side it is minus e raised to power minus k1 plus k2 t. Further moving, I can write e raised to power minus t by tau, and by you can see beta, the same expression that you got yesterday, again you are getting the same expression. See, xa minus xa upon xa is equals to e raised to power minus t by tau, t by tau. Okay, so again you are getting same expression now. It is what? It is now written as e raised to power minus t by tau. So where 1 by tau is this, so tau is m plus xa upon c, same thing. Okay, so yesterday already we discussed how it is time constant, and now you can compare it and you can see in place of 1 by tau you have k1 plus k2. So what we can put in place of tau? It is 1 upon k1 plus k2. So you can also solve in this manner here. Tell me everyone beta, is it crystal clear to all of you? Can we proceed? ये आप सभी बच्चा लोगों को क्लियर है बेटा? Tell me everyone, can we proceed? क्या हम आगे बढ़ सकते हैं? In examination you can choose any path. You can choose any path. Okay, because in given options k1 and k2 both are there, so I'm not here interested to change k1 in terms of k2 or k2 in terms of k1, because in my option k1 k2 both are there. Okay, answer of 86 is option A. 86 कौन सा था रवि? Where is 86? Okay, homework. बेटा homework answer I will tell you at the end of lecture. नोट नहीं किया यार हमने. I have to check. Wait. गेट 2015 for which direction? Wait, I'm checking. गेट 2015. जीरो ऑर्डर. एवरीवन गेटिंग जीरो ऑर्डर. वेट बेटा, लेट मी चेक. आंसर इसका लिखा नहीं था हमने. वेट. यार आंसर की तो है ही नहीं, बुक में देखना पड़ेगा. Yeah beta, A is the right option. Correct. A is correct. It's zero order. If any doubt, you can ask me in doubt clearing session, okay, for detailed solution. But I don't think so that anyone going to ask these homework questions, because these are easiest question. Okay, चलो. So can we proceed, my dear students? आगे बढ़ सकते हैं. So further see that reaction A forming B or anything you can write here. Suppose same thing I am writing like A is forming R, then K1, and here I can write K2. I can do many things. I can create many equations with the help of material balances. What type of material balance I can take here? So one thing you already seen that if you are going to write net rate of disappearance of this A, then it was K1 CA minus K2 CR. But if you are taking this RA at equilibrium time, so you can write CAE and you can write CRE, and in that case it becomes equals to 0. So one equation we already developed like K1 by K2, and that can be written as CRE by CAE, and this K1 by K2 is what? This is equilibrium reaction rate constant, capital K. So this one I hope everyone crystal clear, because yesterday also we got this expression. Now see magical things about this expression. Before that, I want to show you one numerical. Okay, a small pyq. Please tell me this 89th number. A B represented by exothermic reaction. A is forming 2B. This is A is forming 2B. Okay. So to achieve maximum decomposition, it is desirable to carry out the reaction. Tell me, beta. Because my derivation is something related with this numerical. So just first I want to show this numerical. Before that, these two small numericals. Please tell me answer. Very easy. It's very easy. I told you earlier. It's exothermic. We discussed in just I think second lecture, first or second lecture. Starting of CRE was there. When we started CRE. To achieve maximum decomposition, it is desirable to carry out the reaction. It's very easy. Yeah. Low. Why you are telling with a low pressure? Okay. Very good. But you are low temperature, low pressure. Everyone telling me same answer. शिवा तरुण मेहना करुण्या मोहन वेरी गुड बेटा सभी लोग बोलेंगे एवरीवन आई वांट आंसर फ्रॉम एवरीवन so absolutely correct beta it's low pressure because moles are increasing, net moles are increasing, and low temperature because it's exothermic reversible reaction. Okay, very easy, very good beta Kiadash. And this one beta, an exothermic gas phase reaction proceeds according to the reaction disk. The equilibrium conversion for this reaction, only one option can be correct. Can you tell me which one is A, B, C or D? No need of any timer. Problem is very easy. Tell me everyone, please. Shushmit Nandi, Shiva Tarun, very good. Very good. So no need to see these options. We will discuss about these options also, but later why these are not correct. Okay. Mostly you will see the equilibrium, reaction rate constant, dependency upon these things in thermodynamics, but here in CR you will also see some part. So this time no need to discuss this, just see is unaffected by the presence of catalyst. Catalyst can't change the value of equilibrium conversion. Okay, catalyst can increase the rate to reach that equilibrium, decrease the rate to reach that equilibrium. Okay, but it can't change the equilibrium conversion, so is unaffected by the presence of catalyst. Chalo. So now please solve this one. Very easy question here. Okay, I'm giving you two timer for two question. Then we will discuss. You know everything about this reversible relation till now. As per books in Fogler, in Octavian Spill, the things, mostly the written things, we discussed. Even in books, direct expressions are there, but you derived here. So I hope that again you can set something like so that you can solve this problem. Mm, 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 mm. Wait, 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 wait. Waiting. Done, beta. Done. Shall Mukherjee D. Are you telling for previous question? Tell me for this one, beta. 'Sushmit Nandi unable to solve. Why, beta? You know how to deal differential equations, but still unable to solve. What's the reason behind it? 10.1. गुड इवनिंग बेटा श्रेयान. टाइम से आया करो. कल भी लेट आए थे. 2 minute. 10.14, 27.46. एंड डोंट चीट फ्रॉम योर नोट्स बेटा, नोट्स में पीछे पलट के देखेंगे नहीं। Okay, so Ayush getting 23.1. Shayan, Mehna, Shiva, Tarun 27.46. And for 91, two students all only. Neeraj Kumar and second one Mehna 10.14. Anyone wants more time or want solution from my side? This time, but I want a try from your side. Okay, so many students getting 27.465. But how you solved for half life? Half life के लिए आपने क्या लिया? What equation you used? What equation you used for half life? Can you tell me better, everyone? Same. General equation in terms of conversion and taken x is equals to how much? 0.5? Hmm. Can we take x is equals to 0.5? If the max conversion that we can obtain is only 40%, then can you write it's x is equals to 0.5? So shouldn't the x is equals to 0.25? X is equals to 0.125. So what you are going to take here? It's a big problem. That's why I told you a new concept you are now going to learn. Okay. So before this question, I want to share a few more information with you, beta. So just come to the last slide. Okay. Now see few more balance equations I am going to discuss. Just focus here, beta. Anytime, my dear students, you can write CA naught as CA E plus CRE. Is it correct? Can we write like this, beta? Tell me, beta, can we write like this? This equation is correct or not correct? Tell me, this one is correct or this one is correct? Which one is correct one? The first one or second one? Which one is correct here? First or second? Or both are wrong? Tell me. Shushit Nandi, both are correct. Absolutely correct, beta. Because the moles that are going to change in CACR and 1A is forming 1R, so definitely we can write like this, but not always. If this is A is forming 2R, then something different you are going to write. What? Don't worry, I will discuss just after a few minutes. Okay. Now, see here. Further moving, my dear students, I can write this expression as CA naught that equals to, and see here beta, CRE can be written as KECA. We can write now. So CAE, and here I can write KECAE. And with the help of this expression, you can get one more beautiful expression. And beta, this expression only can also be asked in your examination. So you must know how I am going to rearrange these things and able to obtain multiple expressions like this time. See, I got a beautiful expression for this CAE. I hope each and every student is crystal clear, this one as well as this one. Okay, so clearly if you want to know the equilibrium concentration of A, then just two things required for you. One is equilibrium reaction rate constant value, and the second one is initial concentration of A value. See how easily you can get this. Okay, now few more expressions we can get with the help of this expression here. We can also write CBE. So can you tell me what should be the expression for CBE? क्या आप इसे develop करोगे? Yes, you can develop beta. You can develop easily. Not BE. Here I assumed R na this time. So CRE. CRE, the equilibrium concentration of R. How to get it? Very, very easy. You can write KCAE, KCAE, and now in place of CAE, now in place of this CAE, you can put CA naught upon 1 plus K. You know, beta, only this expression can be asked. A, B, C, D, four options are there. They can ask which one of the following is the correct expression for equilibrium concentration of R. And in one option you can see K is CA naught upon 1 plus K. So equations are also important, as I told you earlier. More than thousands of equation you will get in CRE. So you can't remember every equation beta. Also in all subjects you can get many equations. So derivation is the easiest path. Derivation in the examination, easiest path. If derivation takes 30 second to 45 second, if derivation takes more than 3 minute, more than 4 minute, then you need to remember final result only. Okay, so I hope everyone crystal clear. Can we proceed? क्या हम आगे बढ़ सकते हैं बेटा? In similar manner I can also develop the expression for CB and CA. Okay, the expression that you need here in order to solve the previous equation, that previous problem that I just asked you about CB. You know one expression for CB here. Sorry, every time I'm writing BB, it's CR na. So I can write CR. You know the expression for CR and CA, CR and CA, these two equations. So CR is very easy expression beta. Just CRE and then 1 minus e raised to power my उफ, ये तो गड़बड़ काम हो गया भाई. Okay, so CA naught can be written as CA and CR. Further, this CA naught can also be written as CAE and CRE. And one more thing we discussed, that in this expression, if we are going to put CAE plus, instead of the CRE, KE, CAE, so CAE can be written as CA naught upon 1 plus KE, and with the help of this expression you can also write CRE. So what is CRE? CRE was KE CAE, so it is KE CA naught upon 1 plus KE. ये तो हमने डिस्कस कर लिया था. Okay, this one and this one and this one. Now one more thing I want to discuss, that was the concentration of A with respect to time and concentration of R with respect to time. Okay, so R will be CRE, then 1 minus e raised to power minus K1 plus K2t. Can you get this expression for me बेटा? क्या इस expression को निकाल सकते हो आप? Please tell me everyone. Can you obtain this expression beta? Similarly for CA, one beautiful expression you can write like this CR, CAE and plus CA naught minus CAE. Are you getting my words beta? समझ रहे हो ना क्या कहना चाह रहे हैं? What I want to tell you? Same expressions, but see, now more equations we can develop. So can you develop this expression for me beta? क्या ये निकाल सकते हो आप? Just saving slides. Because in your examination they can also ask which one of the following is the right expression for CR. Now see, previous CR expression, previous, in this one there is no expression for CR, just you got XA versus time, XA versus time. So the same equation, but now we are dealing in different manner, so that we can write expression for CR also as well as we can write for CA also. Okay, so I think timer required, otherwise you will take too much time. So I am giving you 2 more minutes. I am giving you 2 more minutes. Anyone if able to opt in, then just write done sir. You can share your emails on Telegram. So max time allotted by me 2 minutes from now. Unable to solve? Just write R in comment section, beta. Unable to solve. That means suppose in your examination they are going to ask, then that time surprised. You will surprised. That's why I told you these equations are something like magical equations, because in books you can't find these equations. ये equations आपके books में नहीं मिलेंगे. Okay, even in Fogler as well as in octave 11 scale, because it needs simple balance things, simple balance equations. Like what? See, anyone wants more time, beta? कोई चाहता है क्या? Because it is doable. It is doable if you are just follow the path that I just suggest you, then definitely you will be able to get this. Don't want to do now. हथियार डाल दिया everyone. Sir, you tell me R, everyone writing R. That means sir unable to do. Don't worry, don't worry. See beta. You know that minus dCA by dt for that given expression, and that was simply K1 Ca and minus K2 Cr. Absolutely correct. Further moving beta, I can write K1 Ca in place of this Cr. See again. Oh my god. Same expression, but again different dealing here. Because this time my aim was different. Okay, so this time I am writing Ca naught minus Ca in place of this Cr. Oh my god, sir. Yeah, beta, this is one more weapon for you. In your examination, what weapons you can use? I will give you all weapons. So don't worry. No need to worry. Okay, so can we write this beta? In place of this Cr, can we write this C with the help of this beautiful expression? Is it crystal clear to all of you, beta? Is it crystal clear, my dear students? Can we proceed? No doubts? Fantastic. Mind blowing. Super. So further moving beta, you can write dCA by dt, and then this becomes equals to K1 Ca minus K2 Ca naught and minus minus plus K2 Ca. Further moving, I can write K1 plus K2. I can take Ca common from first and third term, and minus K2 Ca naught. Okay. Further moving, minus dCA by dt. This time, my dear students, here I am going to take this K1 plus K2 common. K1 plus K2 common. What will left here? It's Ca minus K2 upon K1 plus K2 Ca naught. Okay. And K2 Ca naught upon K1 plus K2 C. K2 Ca naught. This is the same. This is same. How same? Wait, I'm showing you. See this expression. What is K? K was K1 by K2. So K1 by K2 Ca naught and whole upon 1 plus K1 by K2. So I can take LCM here, then it will be K2. K2, K2 cancelled. Now you can see beta, it is nothing but K1 Ca naught upon K1 plus K2. So same thing, same expression. If we are going to substitute this K from K1 by K2, then we can write K1 Ca naught upon K1 plus K2. And this is K2. Wait. K2, K2, K1 by K2. It is Ke, K2, K2, K. Oh, sorry. K1 by K2. Tell me, till now, is it clear? How we can substitute this K, K1 Ca, K2 Ca naught. Okay, it's K2 Ca naught. Wait. ये लिखने में कुछ मिस्टेक हुआ है क्या? नहीं, चलो CRE को छोड़ते हैं, इस पे आते हैं. See this one also. Yeah, this one we can substitute from this one. See, k1 by k2 will be in numerator, then here k1. Yeah, see, it can be written as k2 ca naught upon k1 plus k2, and it can be written as k1 ca naught upon k1 plus k2. बोलो बेटा सभी को clear है? Is it clear that we can put here CAE? We can put here in this place CAE. We can put CAE. So further solving, we can write dCA upon dt, and that becomes equals to k1 plus k2. And now here, my dear students, I can write CA minus CAE. Very, very easy. Very, very easy. Just our equation is similar as XA minus XA. See, the things going in similar manner, beta. But this time I'm dealing not in terms of conversion, in terms of concentration, because I want a final expression in terms of concentration. So no need to worry in your examination. Just as per the options given, you have to choose path, beta. Okay, like here you can see this expression, beta. You can see this expression. So it is similar, same to same, not same, but it's similar. It's similar one. Okay, and in terms of magnitude you can say same, because the same case we are dealing. Now here you have to solve this expression very, very easily. dCA upon CA minus CAE, and that becomes equals to k1 plus k2 into dt. Again you have to take limit. When time is 0, concentration of A is CA naught. After some time t, concentration of A was something like CA. Okay, आराम से देख लो बेटा. Just see it. If any doubt, then you can ask me. So if CR naught is not 0, then equation will be CA naught plus CR naught is equals to CA plus CR. Beta, in that case, if CR naught is not 0, yeah beta, in that case, very good. CA naught plus CR naught will be CA plus CR. For this case only, please, if it is A is forming 2B, then all balance will be changed, because that equation I am writing just with the help of simple material balance. So this is only valid for this one. Okay, A is forming R only. If A is forming 2R, again you have to take material balance. I will show you in this lecture after few minutes. Okay beta. Now see again, if I'm going to integrate here, so it is just minus ln of CA minus CA minus ln of CA minus CA, and upper limit will give the same thing and lower limit will give CA naught minus CA. Okay, minus will remain as usual. Okay, because here second term is negative, not this first term. So differentiation CA will give you 1, minus CA will give you 0. Okay, so CA minus CA, upper limit will give same thing, lower limit negative. So ln A minus ln B can be written as ln A by B, and here you can write simply k1 plus k2 into t. Okay, now this minus I can put here in right hand side, and then I can take here beta exponential. So it will be exponential e raised to power minus k1 plus k2t. And now see the expression that required, we got CA minus CAE, and that becomes equals to CA naught. Oh, CA naught minus CA naught, ये क्या हो गया भाई? CA naught minus, this is CAE, this is CAE, this is CAE. Okay, so CA naught minus CAE into e raised to power minus k1 plus k2 t. Further solving beta, you can write CA as CAE plus CA naught minus CAE and e raised to power minus k1 plus k2t. See how easy it is beta. Is it crystal clear to all of you beta? Tell me everyone. Is it crystal clear? No doubts at all? Same equation? So now can you solve for CB? CR? क्या आप CR निकाल लाओगे फिर ये? Solve this second one. Okay, solve this second one beta. Just try it, because if I am going to solve every equation, then you will not learn anything. Just you will copy it, copy. So this time please use your mind and obtain this second expression. Very very easy, very very easy. CR is equals to CRE and 1 minus e raised to power minus k1 plus k2 t. And for this expression you can also mention here that CR naught is 0, because in this material balance we are not including that CR naught. If it is there, then here you have to write in left hand side, you have to write plus CR naught plus CR naught. Okay, then again all equations will be changed. That's why I told you many combinations are possible. Okay, thousands of combinations are possible. Lakhs of combinations are also possible if they are dealing like 1.11, 1.12, 1.33 for order. But mostly in your examination, don't worry, every case, the important case discussed by me here beta. So mostly you can see same to same copied in the gate examination. So that's why I told you just revise your notes beta in depth. Every day revise your notes. Revision is key for success. Last 25 seconds. In Hindi, my dear students, जितने भी इक्वेशंस हम आपको लिखवाते हैं पढ़ाते हैं, ऑलमोस्ट आप देखोगे उसमें से ही आपके एग्ज़ाम में आएगा. बट चूंकि आप सब कुछ डिराइव करना सीख रहे हो, तो अगर वो थोड़ा बहुत इधर उधर कर भी दिया तब भी आपको फंसा नहीं पाएगा. ओके, गॉट इट? किसी का नहीं आया? नो वन एबल टू गॉट दैट सी आर यार? Done, very good, Shushmit Nandi. One student only one student. What is this? What is this? It's not good. It's not good. Last 10 second. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. सर 1 मिनट, 1 मिनट और चाहिए क्या दास? चलो भाई दिया, करो आप, बट इतना भी टाइम मत ले लो. Yes, Susmit Nandi, absolutely correct. Absolutely correct. Now, but I can't give you more time. Okay, see here, beta. You can write CB. Sorry, again I'm writing CB. You can write CR as CA naught minus CA. CA naught C. CR is equal to CA naught minus CA. So CA naught minus CA. What was CA? CA was CAE minus CA naught minus CAE and e raised to power minus k1 plus k2t. Okay, now here clearly you can see beta here CA naught minus CAE is common. So further you can write CA naught minus CAE, and after taking it common, this term will be just 1, and here it's minus e raised to power minus k1 plus k2t. And what is CA naught minus CAE? From this expression you can see it CRE. So CR will be CRE and 1 minus e raised to power minus k1 plus k2t. That means beta you must learn how to deal these equations. Okay, so now please tell me, is it crystal clear to all of you? Is it crystal clear? Is it crystal clear, beta? Can we proceed? Can we proceed? Okay. Now see this beautiful numerical. Okay. And here, my dear students, the second part that you are seeing here, it is very very important for you, because here we are asking about half life, and mostly they will ask like simply the half life of A. That's it, like this, the half life of A. So if this is reversible reaction, then how to get half life dealing is something different. See, whenever you are seeing half life means आधी जिंदगी, आधा conversion. What is the meaning of half life? Half life means half path already covered. And my dear students, when you are dealing here for this reversible reaction, wait, processing going on. Wait. Okay, done. See this graph. Your path that you can travel, it is not 0 to 1 beta. This path you can't travel. So that's why, my dear students, here if you are putting x is equals to 0.5, then it's totally wrong for reversible reaction. Okay, so here new concept required. Here again new concept required. As I told you, these things are not available even on Octave and Fogler. So this is just a simple basic thing that I am discussing here, beta. So please focus. Okay, if any doubt, just ask me immediately. So you can't complete this path. The path that is completable from your side is only this one. This path can be. This path can be. You can do from just 0 to this XA only. Or in terms of concentration, if we are dealing, then it's CA naught to CAE only. Are you getting my words, beta? Are you getting my words? So half life this time, if you are dealing for half life, then my dear students, this is not half life. This is not half life. This is your half life. This is not your half life. Are you getting my words, beta? Why you can't take x is equals to 0.5? Because suppose in some given chemical reaction, the conversion is equilibrium conversion is 40%, then you are saying half life, that is you are dealing for 0.5, that is even not possible in that given chemical reaction. 50% is not possible. So how you can write this here? How you can write this? Definitely that will be more infinite, because never the conversion going to exceed from 0.4, because that is equilibrium conversion there. Okay, is it crystal clear to all of you, beta? Please everyone tell me, beta. So that means we need a beautiful new concept for half life. Okay, here. So this time, can you suggest me, beta, what we can write in place of CA for this reaction? What we can place in place of this CA? क्या रख सकते हैं हम इस CA के place पे? Can you tell me, beta? Crystal clear. Very good, very good. What we can put? CAE by 2. CAE by 2. Very bad. Not correct. My dear students, wait. Suppose initial concentration is 40, CAE is 30, and you are telling CA is CAE by 2, that is 15. Is it correct? You can go only up to 30 and you are telling 15. Huh? Again, how, yeah? Are you getting my words? Ayush and Shiva Tarun? No. Tell me again. Tell me again. Here the max possibility is up to 30 and you are telling that equilibrium half during half life concentration is 15. This is reactant. A is reactant. Okay. So क्या था सी ए नॉट बाई टू. Okay क्या दास जी. सी ए नॉट बाई टू. So सी ए नॉट is 40 and 40 by 2 is 20 and max we can go up to 30. So how you can put beta this सी ए नॉट by 2. सी ए नॉट by 2 is same to same na. X is 0.5. So क्या दास it is also not correct यार. Please tell me beta again. Try. नई चीज़ है ना, न्यू थिंग. आपको फील हो रहा होगा. फॉर यू इट इज़ न्यू. Because every year when I teach this topic, then students told me that sir, I had not seen anywhere this concept, half life concept, not even on YouTube as well as in any coaching lecture you can find. It is not available. Okay. CA when XA is XAE by 2. XAE by 2. Very good. Very good. Fantastic. In terms of concentration, can you tell me, beta? 7.19 is not correct, beta Ayush. Neeraj, 7.19 is not correct. Tell me, beta, any other equation? Any other equation, my dear students? Still, I am waiting in terms of concentration. Can you tell me any other expression? क्या दास सी ए नॉट प्लस सी ए बाई टू. क्या बात है भाई, क्या दास छा गई बेटा, छा गई. So my dear students, it should be CA is equals to CA naught minus CAE by 2 or plus CA by 2. It is a very big question. The concentration that already covered there is C naught minus CA, like 40 minus 30, so 10 converted by you. So it should be CA naught minus CA by 2 or CA naught plus CA, because Kyadas had given CA naught plus CA by 2 and I had written here minus CA by 2. So please tell me, this should be minus or it should be plus. It should be minus or it should be plus. If it is correct, then please tell me. It should be minus or plus. Tell me everyone, I want reply from each and every student. It should be minus or plus. If unable to get any conclusion, write R in comment section. But respond immediately, beta. Still thinking. Tell me. I use don't know, sir. Tell me everyone. Shiva Tarun is typing. Okay, waiting for your comment. Sir, can you explain the example of 40 and 30 values? Yeah, I will explain that 40 and 30 values again. So, my dear students, first tell me this should be minus or plus. It should be, don't know. Okay, beta, Shiva Tarun. Neeraj, tell me, beta. थोड़ा जल्दी रिस्पॉन्ड किया करो. किया था plus नीरज plus, very good, so it should be plus. See, you asked for 30-40 example. Suppose beta 40 is this one and 30 is this one. Okay, Shiva Tarun. So only 10 the moles per meter cube that you can decrease for A, only 10. Only and only 10. Okay, so during half life, that means it should lie between these two, and that is clearly 35. That means from 40 to 35, half path traveled. From 35 to 30, full path traveled because equilibrium reached. Equilibrium reached. Okay, so see, 40 plus 30 by 2, it will give you 35. Yes. That means expression is absolutely correct. Shiva, Tarun and all, please tell me, beta, is it crystal clear now? Everyone, is it crystal clear? Tell me. क्या बात है, क्या बात है. So enjoy this topic, मजा आया. So tell me beta now, what should be expression here for T half? Please derive it. Put this CA. Okay. Mehna, sir, tell me again. Beta Mehna, half life का मतलब क्या हुआ? What is the meaning of half life? That means the total path that can be traveled. Out of that travelable path, half path already traveled for reversible reaction. For reversible reaction. So half path already can be traveled, that is this relative this CA, because CA is that final path, final point that you can reach from this CA node. See, in case of irreversible reaction, what is the value of CA, Mehna? Please tell me. In case of irreversible reaction, CAE value, please tell me, Mehna. If reaction is irreversible one, CAE value is, tell me, CAE value is, CAE value is, no, beta, I am asking not CA. I am asking CAE value for irreversible reaction. If A is forming only R here, R can't form A. That is irreversible. Yes, very good. Very good. Ayush and Shiva Turun Mehna, are you also getting? It's 0. See, same thing. You can put here 0. You will get CA is equal to CA naught by 2. That was for irreversible reaction. Okay, beta Mehna. So, total path that can be traveled, this one. So, if you are starting from 40, then it must be ended at 30 because equilibrium reached. Equilibrium reached. From 40 to 30, equilibrium reached. So what is the midpoint? That is half life. So during half life, the concentration should be 35. How you can get this 35? 40 plus 30 by 2 will give you 35. So 40 plus 30 by 2 will give you 35. Is it crystal clear now, Mehna beta? क्या अभी क्लियर है that if this is reversible one, then you have to put CA naught plus CAE by 2. If this is simple irreversible, then CA is equal to CA naught by 2. So very very easy. Yes sir, very good. So now please find this T half equation. इसके लिए T half क्या आ रहा है? सभी लोग फटाफट बताएंगे. Everyone, you can share picture. क्या बात है नीरज? Absolutely correct, and it is a beauty of final expression that in your examination no need to derive it because it is again in the standard form. If only first order simple irreversible reaction, then you know na, in that case just ln of 2 by k. This time not, it is not k, it is k1 plus k2 as written by Neeraj Kumar. Absolutely correct, your answer is absolutely correct beta. This time it will come ln of 2 upon k1 plus k2. समझ गए बेटा? सभी बच्चा लोग को क्लियर है? Is it crystal clear to all of you beta? Is it crystal clear? Everyone please confirm me. Is it crystal clear? No doubts? Topic is clear to all of you? That's great. बहुत ही अच्छे. Fantastic, mind blowing, super. Anyone wants this derivation from my side or everyone already got it? कोई derive कराना चाहता है तो लिख दो derive sir. Otherwise I will move towards next topic because very easy. Just you have to put in that CA expression. Sir, how can we obtain T half Kiadas? Okay beta, Kiadas C derivation. I'm going to do derivation for you. So expression was CA is equals to CAE. CA is equals to CAE and plus CA naught minus CAE plus CA naught minus CAE e raised to power minus K1 plus K2 T. You have to put here CA is equals to CA naught plus CAE by 2, that becomes equals to CAE plus CA naught minus CAE and e raised to power minus K1 plus K2. Here now it is T half. Okay. Now CA naught you can write in left hand side. So minus CAE, sorry, this CAE in LHS will be minus CAE. By LCM it will be minus 2 CAE. So CA naught minus 2 CAE plus CAE will give you CA naught minus CAE. CA naught minus CAE all upon 2. That becomes equals to CA naught minus CAE e raised to power minus K1 plus K2 T half. Numerator cancelled beta. So 1 by 2 exponential here, if you don't want to write, then it will be ln of 1 by 2, and that becomes equals to minus of K1 plus K2 T half, or minus multiplication both side will convert expression is ln of 2 K1 plus K2 T half. So from here beta you can write T half as ln of 2 upon K1 plus K2. Is it crystal clear now beta? Mehna? No, Mehna not. It's Kia Das. Clear, sir? Okay, clear, sir. Very good, very good. Fantastic. Now, again, I am giving you time. Please solve this question again. Previously, I know for time required for CB, you used that XA expression. Okay, in that expression, you had put in the value of XA according to this CB. This time, simply you can use that CB equation and tell me answer. Very good, Ayush. Absolutely correct. Yeah, but anyways, you can use XAE by 2, either XAE by 2 in terms of XA, it should be XAE by 2. Okay. Here XA will be XAE by 2. Previously, the value of XAE was how much? 1. So it was XA was 0.5. Okay, because the total path is 0 to XE. So half of this path is XE by 2. Okay, very good, very good, absolutely correct. 91 and 92 both are correct now. So I hope that everyone now able to understand the concept behind it, beta. So please tell me, this topic is crystal clear to all of you, beta? 0% darkness. Everyone please confirm me. 0% darkness now, or still you are feeling any difficulty? How you solve for this CB? CB को कैसे solve किया आपने? Are you using this expression? If you are using this expression, then tell me from where you are going to get this CB. आपको CB ही चाहिए ना? So you know that this CB can be written as CA naught KE upon 1 plus KE. Now what is the value of KE here? So KE was K1 by K2. K1 is 0.03 second inverse. This is 0.01 second inverse. So it is 3. So CA naught is 2. So 2 into 3 upon 1 plus 3. 2 3 is a 6 by 4. That means 1.5. ऐसे ही लगाया ना आपने बेटा 1.5. So now just put here 1.5 and 1 minus e raised to power minus k1 plus k2, that is 0.04 and time t. Okay, and how much you need CB? 0.5. Now one equation, one unknown. After solving it will give you the value of time t. ऐसे ही लगाया है. From conversion you can also do beta, but please make sure that whenever you are going to solve, don't cheat any equation. Whenever it required, you have to develop at the time of solution. आपको solution के time में से derive करना पड़ेगा बेटा. So if able to derive that conversion faster than this one, then you can use that conversion type. If this one is faster one, then you have to use this one. Are you getting my words beta? What I want to tell you? Divide by 0.04. Yeah, it is coming 10.1366. So I can write 10.14. I can write 10.14. 10.14. So it's 10.14 second. The equation that is already available in your notebook, you can't use directly beta, because in examination you don't know that equation na yaar. So whenever any question you are going to solve, just derive that expression that required for that one. वहाँ तुरंत का तुरंत derive कर दें. And for few special cases you can remember also, but only for few cases whose derivation is very very lengthy. Okay, so this is answer number 91. Okay, now second one, as I told you that please remember it. So you already remember that t half here is ln of 2 upon k1 plus k2, because it is similar to simple first order irreversible reaction. Ln of 2 and upon what was k1, so 0.03 plus 0.01. After solving it will come how much? 17.325. 17.325 second. This is your final answer. Okay beta, सभी बच्चा लोगों को clear? Can we proceed? Can we proceed? Tell me everyone, no doubts? Okay, so now few more beautiful concepts here. I am not going to left a single concept beta, because CRE is also very very important subject for interviews, and especially in BARC and PCIL. Okay, and PCIL they are also asking about from thermodynamics about their respective cycle. But in Bark, if you know this subject CRE well, then definitely the chance of selection is very, very bright. So A is forming, suppose I am writing this time beta it's 2R. Then what change will come? क्या चेंजेस आएंगे हमारे प्रीवियस दिए हुए केस में? So what changes will occur, my dear students? This time again, if clearly mentioned in your examination that both side are elementary one, this will be given. This will be given. Okay, that forward is first order, then definitely here backward is second order. Okay, or either this word they can use, or they can use like both reactions are elementary, forward and backward. If elementary, then definitely stoichiometric coefficient is your respective order with respect to that side. So this time beta RA you have to write like K1 CA and minus K2 CR square. This change will occur. Now again, if you are writing RA at equilibrium, at equilibrium, then it will be beta 0. And here you can write K1 CAE, but now it is not minus K2 CR. It will be now minus K2 CRE square. Are you getting my words beta? What changes occurred here? चेंजेस क्या आ रहे हैं, समझ पा रहे हो? So this time K1 CAE can be written as K2 CRE square, or K1 by K2, that is also our KE. This time it is CRE square by CAE. So as per given case beta you have to do this dealing. आपको दिए हुए केस के अकॉर्डिंग ये डीलिंग करनी होगी. Okay, now I am giving one question to you. CA naught is equals to ACA plus BCB, or ACAE plus BCRE. BCRE. Now tell me the value of A and B here. Tell me the value of A and B here. Come on, बताओ. Again here one more thing is given, that no R was available. If R is available, then no need to worry. In all expressions, in all material balances, just you have to write CA naught plus CR naught instead of CA naught. आप CA naught की जगह CA naught plus CR naught लिखोगे, because that time that will be your material balance. Tell me what A and B. Sushmit Nandi. Sushmit told us that, sir, you can write like CA naught is equals to CAE प्लस 1/2 CRE, ऐसा बोला सुस्मित ने. सो इज इट करेक्ट? स्टिल थिंकिंग? टू मच थिंकिंग. Shiva Tarun 1 and 2. Okay, Shiva Tarun told us CAE plus 2 CRE. Ayush also same as Shiva Tarun, 1 and 2. So two answers till now. Which one is correct? Is it correct? Is it correct? Or both are wrong? Last 15 seconds. If unable to understand, then you can write R in comment section, beta. If you are unable to get a conclusion. Socho, think. Okay, that's enough time. So three students only able to give answer. So my dear students, this is not correct. Okay, this is correct. So A should be 1, B should be 0.5. That means Shushmit Nandi. Congratulations, beta. Hauser, beta. If 1 moles of A is going to consume, 2 moles of R will form. So my dear students, if this is suppose 20 and after some time suppose approximately 5 Ca not consumed. So here it will be 15. It will be 15. 5 consumed and that 5 is going to give you 10 R. So if you are going to write 10 R here, CRE will be 10 and here you are multiplying with 1. Okay. And here if you are multiplying with 2, oh my god, 15 plus 20 is 20. No, it's 10 by 2. See, 15 plus 5, 20. Yeah. Mass balance is clear. Is it crystal clear to all of you, beta? Is it crystal clear, my dear students? So please don't do this silly mistake while taking material balance, beta. Because as I told you na, in the first lecture that the base of all subjects, mostly of all core subjects, is process calculation. That is material and energy balance. Okay, crystal clear? Done? So don't do the silly mistake again, beta. Shivatrun and Ayush and all. Shoshin Nandi, very good, beta. Happy with you. Okay, so can we proceed? Chalo. So now we are going to discuss a few more reaction networks. Few more complex reaction networks. You had seen Danvig reactions previously. Okay. One beautiful problem I want to ask you. Just wait. Problem 91, 92. So this should be problem number 93. 93. Okay. Okay. See, one beautiful question here I am asking. We have a series reaction. A is forming R is forming. Yes. In short, I am writing expression problem. A is forming R is forming yes. And the value of K1 is given as 200. The value of K2 is given as 5. Second inverse. So clearly both are first order reactions. Okay. Now, if above equation, now I hope you remember that previously we had done approximation. Okay, so now again this two-step first order reaction that is in series in which the reaction rate constant value is like 205. Now we are going to approximate overall behavior. So if above equation is approximated, as the value of k is can you tell me beta answer? Can you solve this beta? Tell me answer. The origin of this question is octave 11 spell. I had taken this from octave 11 spell. Just change datas and language also. That is, this is not as question there. This was in theory part. So I had taken from theory and converted that theory into the question. Still waiting for your answer. Final timer. अनेबल टू डू, किसी का नहीं लगा यार। One student giving 200. See beta, this is very easy. 200 is not the correct answer beta. See answer, solution. Here the k is very easy to solve. It is 1 upon 1 plus k1, 1 upon 1 plus k2. That means just 1 by k is equals to 1 by k1 plus 1 by k2. That parallel combination you are using here, this is a series reaction, but okay. So here 1 upon 200 plus 1 upon 5. So it should be 1 upon 200 will be, I think, ये कितना आ रहा है बेटा, 0.0, so it's 10, one more 0, it's 100, one more 0, it's 1000, so 0.005, and it should be 0.2. Further solving, 1 upon 0.205. Can you tell me beta how much, कितना आ रहा after solving? 4.9. So beta 4.9 is the right answer. इसका आंसर क्या है सही? It's 4.9. Okay, so please learn this beautiful technique beta, that how we are going to approximate, available on Octave 11th field, page number 197. But how did we get this equation? But this is an approximation equation that used for the same type behavior. With the help of experiments, you can see the behavior is still same. Okay, so if the two steps of first order reactions you are seeing like this in series manner with very different values of reaction rate constant, so in that case you can rearrange them just like A is forming, yes, and definitely the value of K will be, the value of K should be, see how it is correct. It should be, you had approximated when so you use the lower path na, slowest path, so this is your slowest path, so your net K value will be nearby 5. See, nearby 5, but it should be net less than 5 because this one fastest path is there, but it is not infinite fast path. Okay beta, Shushvit Nandi, is it crystal clear my dear student? Is it crystal clear to all of you? Can we proceed? Fantastic, mind blowing, super. So next topic I'm going to discuss complex reaction networks. Reaction networks. Now I can make any type of network beta. It is very, that can be very complex, like A is forming B, is forming C, is forming D, is forming A. Okay, or you can write like A is forming B, is forming A, is forming here C, and again this C can form this A. That is complete cyclic. Okay, A B you had seen, now it's A B C or A B C D or A B C D E or A B C D E F, or again you can see like A is forming B, is forming uh, E, and this B is also forming C, and C is forming, please write here also D, so that simultaneous behavior you can see. It is forming D, and again my dear students here this is forming A. Few more possibilities, like A is forming B. This is reversible path. Then B is forming C. C is forming D. And C also forming E. Then E forming F. So many possibilities are there, beta. And again, you can write here that C is also formed, F is also formed by this C. Again, you can write like this. Then this F is also forming by this B. Further, you can also combine this A with F. Okay. So for any type of such reaction networks, beta, the dealing is very easy. Just if you know their basics. And one beautiful problem was also asked. I think it was a gate 2026. I will show from this one. Same reaction was there. Wait. I'm showing you. And in interviews, they're also asking same things. Wait. Mhm. See, beta, this question. This was asked in gate 2021. ये गेट 2021 में पूछा हुआ प्रश्न है. So definitely again they can ask na. So very important. That but the beautiful thing is that it is not a very complex. Very easy. This is very easy. Okay. So soon you will be able to solve it. Don't worry. Now just focus on these complex reaction networks. Now here respective rate constant, suppose 1, 2, 3, 4, 5, yeah, 5, 6, 7, 8. These are especially K1, K2, K3, K4, K5, K6, K7, K8. These are not magnitude this time. Okay, but it may be magnitude if written in your problem, that the number with reaction are magnitude of reaction rate constant. Okay, and here clearly it is 1, it is 2, this is 3, this is 4, this is 5, this is 6. Here this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9. ओके. इस कॉम्प्लेक्स रेशनल नेटवर्क में दिक्कत है मुझे सर समझने में, कोई बात नहीं, अभी आसान हो जाएगा. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now how to deal this? Just focus here, beta. It's very easy. Suppose here you want to write RA, then how to write it? Very easy. See, RA minus RA means rate of disappearance of A. So it's K1 CA, as well as one more path is there, plus K8 CA. Suppose I am telling all are first order. Okay, because stoichiometry ABCD written clearly. If not first order, then use respective like CA square you can use for that case. Okay, but mostly for reaction network they will ask all first order mostly. But if any other, don't worry, they will provide some more extra information so that you can solve that problem in less than 1 minute. Okay, and disappearance by this one path and by this eighth number path, but its formation also by this second path and this seventh path. So minus K 2CB as well as minus K7 CD. Similarly, my dear students, you can write for B, for C, for D. Like suppose I am writing B, rate of formation of B. So please everyone now write in similar manner and then show me beta. If disappearance then multiply complete equation with minus. No need to worry. So ये सभी लोग लिखोगे यार. Everyone please write A B C D here and then immediately write A B C D here. And also you have to write A minus RB plus RB here also. You have to write both. Okay. Here also you can write both. Okay. And plus RC. So please fill in the blanks. Do this immediately and then compare with me. Okay. आप लिखोगे फिर compare करोगे. I'm also doing, but don't cheat. Only you can compare. And if any doubt, then you can ask that one to repeat. You know, if somewhere written K67, what is the meaning of K67? It means K6 plus K7. So if in your examination you are seeing like this, then don't worry. Then don't worry. If K123 is there, if somewhere you are seeing K123 is there, that means it is nothing but K1, K2, K3. Standard representation. These are standard representations, beta. Okay. Mm-mm-mm. वेट लेट मी चेक। कौन सा है? सी। 4 जा रहा है, 5 जा रहा है। हाँ, 6 नहीं, 6 तो आ रहा है। गलती से 6 लिख दिया, ये 5 ही है। Just check it, beta. If done, then write done in comment section. Is it same to same? Done, my dear students. Very good. 2 for this one also. टेल मी व्हाट इज इट? सेम, दोनों कंपेयर कर लो सभी लोग फटाफट. If all correct, that means now you are able to write for any type of complex reaction network very very easily. Okay. Previously you had also seen one beautiful Danvig reaction. That Danvig reaction also you can deal in similar manner. Okay, beta, can we proceed? Done. All correct. सभी सही है. Hmm. Now you know still you will not be able to solve the problem that was asked in gate 2021. Are you able to solve this? Yeah, you are able to solve, but if you are going in right direction. So if till now all clear, then write CC so that we can move forward and solve that beautiful problem asked. In next lecture, I will also discuss many graphs for these complex reactions. In next lecture, we will also discuss many graphs. Crystal clear. So please try this बेटा. इसे try करेंगे एक बार. Okay, try this. If orders are different, then the equations that you are going to solve will be very very complex. That's why they can't ask in your gate examination. Okay, because for that maybe you need some software to solve that in less time. So mostly if they are going to ask in examination, reaction network, all will be first order, just like this beta. You can see everything is second inverse, that means all are first order. So they can't make second order actually because of time boundation. Unable to do, please write R in comment section immediately beta. Don't take too much time. Don't take too much time. Only 10 minutes left in today's lecture and still I have to discuss one more topic here. This is also extended session from my side. Unable to do. That's why I told you everything is important. So now how to do it? Now here comes. You can solve. I can also solve by that a simple mathematical dealing. But that is a very lengthy procedure. From which this lengthy procedure, one conclusion we have beta. And that conclusion now I am going to discuss with you. That is principle of detailed balance from microscopic reversibility. For microscopic reversibility, see, it will work only for cyclic reversibility. Here in these two, they are following microscopic reversibility, that is in cycle form, all thing in cycle. Okay, yeah, again new concept. This concept is also not available even in octave 11 spill or in fogler. So what is microscopic reversibility cycle beta? Here A, B, C, D, A, B, C. If these types of cycle you are getting, then here principle of detailed balance work. What is principle of detailed balance, beta? What is principle of detailed balance? What is detailed balance principle? Detailed balance principle. What is this balance principle? It tells us. It tells us that for a particular system that is at equilibrium, only and only you can say for equilibrium cases, when it is at equilibrium, then every molecular process occurs with the same frequency as its reverse process. Like here the reaction network you are seeing, A is forming B reversible, B is forming C reversible, C is forming A reversible. So here this principle imposes a beautiful equation. How? See, in that case, the product of forward reaction rate constant must be equals to reverse rate constant. Okay, what does it mean? For these two reactions, कौन सा कलर यूज करें रे भाई? सब कलर तो यूज हो गया. I think purple will be good here. So here my dear students, K1 forward, K3 forward, K5 forward, K7 forward, backward, K2 backward, and K3 backward, K5 backward. हाँ K5 नहीं K6 है यार. ये क्या हो गया भाई? 1 forward, 3 forward, 5 forward, 7 forward. Okay, 2 backward, 4, ये 4 है रे भाई, 4 backward and 6 backward and 8 backward. And like here my dear students, according to this detailed balance principle of detailed balance, you can write K1, K3, K5, and that becomes equals to K2, K4, K6. Are you getting this beta? I can also prove with the help of few mathematical dealing, but here I am not interested to invest this time. Already proved by me. Okay, but here I am not going to invest time. So because you can directly, you have to remember, because proof is very lengthier one. Okay, so you can easily remember this beta. Okay, you can easily remember this, that if any reaction network in this cyclic manner, all reversible, then forward product will be equals to backward product. Okay, for a cycle of reversible reaction, the product of the forward reaction rate constant in one direction must equal the product of the reverse rate constant in the opposite direction. Is it crystal clear to all of you beta? Is it crystal clear? Tell me everyone. Why it is happens? If someone asks you, so because of equilibrium requirement. It is happening here because of equilibrium requirement. That means during equilibrium, the net flux through any closed cycle must be zero. Okay, in short, if you want to say anyone that why this requirement here, how we get this, so you have to tell because of equilibrium requirement, because at equilibrium the net flux through any closed cycle must be zero. Okay, done. So no need to worry anything, directly you can write it. Okay, directly you can write it. Done. So it also ensures us, this rules will also tell you that the equilibrium constant for all reactions are mutually consistent. What does it mean mutually consistent? That means at equilibrium, anytime you can take a separate single reaction like K5 CC minus K6 CD, and that can be written as 0 according to this rule. If this cycle is happens, then these short tricks you can use. Otherwise, the things will be very, very lengthier for you. Okay, so I am telling you these short tricks. Okay, like here you can write K5 C. How I can write K, इसके लिए क्या, ये छोटे वाले के लिए कर दें क्या? ये छोटा 3 ही बार लिखना पड़ेगा ना, ऊपर वाले के लिए 4 बार फिर से लिखना पड़ेगा भाई. आई डोंट वांट टू राइट अगेन 4 times. Okay, so see, for this one, uh, if I'm using only this reaction, so it will be K1 Ca minus K2 Cb. Okay, and net rate of formation of A will be 0. So I can write this 0. Similarly, my dear students, from this one I can get K1 by K2 is equals to Cb by Ca. Okay. Similarly, I can write for this path also. These are short tricks, beta, that you can also use individually. So K3 CB K3 CB minus K4 CC इक्वल्स टू 0. वन मोर यहीं पर एडजस्ट, चलो ऊपर एडजस्ट कर देते हैं इसका वाला. सो इट विल बी, यहाँ देख लेते हैं K6 CC, नो K5 CC, K5 CC minus K6 CA 0. So this equation will give you, the second equation will give you K3 by K4 as K3 by K4 as CC by CB, and this will give you K5 by K6 as CA by CC. Tell me that these three equations how I got, is it clear? क्या ये clear है? This one and this one. If it is clear, then just tell me. I want to do this on the same page. So सर जी प्लीज़ अभी यहाँ आइए, आप टॉप से देखिए अभी बच्चा लोगों को. Okay, crystal clear. And now my dear students, if I am going to multiply these three equations, so it will be K1 by K2 into K3 by K4 into K5 by K6, and that become equal to CB by CA, CC by CB, CA by CC, 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 CA, CA, CB, CB cancelled. So it will make it 1. Or further you can write K1, K3, K5, that becomes equals to K2, K4, K6. Oh my god, see, same expression. That means because of this principle of detailed balance, we can also write these as a separate equations. Okay, so these important things that I told you in detailed, too much detailed manner, I discuss in too much detailed manner, beta. Okay, you can ask anyone, or you can just search it anywhere. You will not get like this. But now I will give you already approximately all things about these reaction mechanism. So now I hope that in examination you will be able to solve if they are asking any such type of reactions. If yes, if all crystal clear, then please write CC in comment section. Then again I will show that numerical that was asked in 2021. Tell me beta, is it crystal clear to all of you? सभी बच्चा लोग को क्लियर है कि नहीं क्लियर है? Tell me everyone. Is it crystal clear? Can we proceed, my dear students? No doubts at all? And one thing you must know beta, you can apply only for any cyclic reversible network. Okay? You can apply only for cyclic network. Done? Chalo. So as I told you, if someone asks to derive completely, so you can say that statics, it here we need statics, and statics is a, you know, a very rigorous one, very complex one to do things. That's why directly the conclusion I had given here, that is detailed principle, detailed balance principle, principle of detailed balance, microscopic reversibility cycling. So if crystal clear, then again this time now see कितना छोटा सा क्वेश्चन है. That's why see 1 mark question in examination they asked for just 1 mark. Huh? Because if you know, then okay. If you don't know, then 5 minutes, 10 minutes, 15 minutes, you're still unable to solve. See, Sivatarun, how fast I got answer, how fast I got answer from Sivatarun. पहले सोच रहे होगे आप. First, I think you thought that why this problem asked just 1 mark. This is reaction network question. But here one principle you can apply. Very good, very good, very good, very good. सभी बच्चा लोग absolutely correct. Mehna is typing. Tell me what a Mehna answer. Sir, what is the note you wrote on dynamic reaction? Answer point 5. Yeah, but Mehna, answer is correct. See, there is nothing. I just written any dynamic reaction or any complex system can be solved in similar manner. That means कैसा भी reaction network बना दे, कैसा भी बना दे, कितना भी बड़ा बना दे, you will be able to write it. Okay? आप सब कुछ कर लोगे. I will give you one homework, big network as a homework, and just take a picture and share on Telegram. Just answer की, no question, no need to share, just answer share there. Okay, done. चलो तो अभी सॉल्व करते हैं और गुड नाइट करते हैं. नाउ आई एम गोइंग टू सॉल्व एंड आफ्टर दिस good night to all of you. So clearly this is a cyclic reversible reaction, and if cyclic is there, so we know that forward constant, that is here k1 and k2 and k3, they must become equals to k minus 1, k minus 2, k minus 3. So here you have to write k minus 3, and it can be written as k1, k2, k3. and whole upon k minus 1 k minus 2. And my dear students, after solving, k1 is 0.1, k2 is 0.2, oh sorry, k2 is not 0.2, k2 is 1, and k3 is 10. Whole upon k minus 1 was 0.2 and k minus 2 is 10. So 10 10 cancelled. 0.1 into 1 will be 0.1. 0.1 by 0.2 can be written as 1 by 2, and 1 by 2 is 0.5. So it is 0.5, and the unit will be k cancelled. 1 k unit will be there, and all is second inverse, so its unit will be second inverse. Maybe in examination, if they are asking minute inverse, then don't forget conversion beta. So please be careful with unit. In examination beta, please be careful with units. Okay, so tell me beta, is it crystal clear to all of you beta? ये क्या लिखा था मेरे देखते देखते तो डिलीट कर दिया किसी ने, सामने डिलीट हुआ, क्या लिखे थे रे भाई? Is it crystal clear? Are you ready for homework question? Okay, very good, fantastic. So beta see, for this you can't write, okay, as this is not a reversible one, this is not a cyclic one, so be careful, be careful, okay, be careful. And if these are at equilibrium, then they all can be written as equals to 0. I'm not writing here, but if this is at equilibrium, if they're asking at equilibrium, if you're writing at equilibrium, then all can be written equals to 0. Okay, this one also clear. These all RA, RB, RC, everyone you can write at equilibrium. Their net formation, their net disappearance will be 0. Okay, only and only for reversible one you can do this short trick beta, not sorry, for cyclic one. If any other, then you need a complex complete solution, and maybe they will provide some intermediate steps if they are going to ask, but the chances are very very less. If they are asking, then definitely they will provide some intermediate data so that you can solve, or they can ask some easy thing that you can write directly. And one more thing about that parallel reaction, that is selectivity and yield. That topic I will discuss later after dealing reactor CSTR and PFR, because yield and selectivity I will discuss there, because for PFR and for CSTR, the yield selectivity, the definition, the equations are a little bit different. So yield selectivity is also we will discuss for batch reactor also, but in reactors chapter, PFR, CSTR, PFR, batch reactor, PFR and CSTR. जब आप वो पढ़ लोगे, when you will read that CSTR, PFR, then only will be able to learn that yield and selectivity concept completely. For this time, yield and selectivity is same as you had already seen in a process calculation. How? I will show you. I will show you later. Okay. Neeraj, you are asking something, sir. For 3, can we? For this one, no. This is not complete cyclic. B is going to give you D. B is also going to give you D. Here, B is also going to give you D beta. But D can't give you B here. This is not completely cyclic. It should be just A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D. Okay? No, still you can't write. Still you can't write beta. It must be completely cyclic. That means only one path will be there. No more than one cycle will be there. No more than one cycle will be there. Okay? Clear? Chalo. So now take one beautiful homework. Just wait. So 95 number is homework. So I am making one beautiful reaction network here. A forming B, forming C, forming D, forming E, forming F, forming G, forming C, forming A. That's it. Okay. Yeah, but a simple cycle is there. Cycle means this is cycle. Simple cycle is going on. Only for that one, beta. Only for that one. Okay. Here you have to write RA expression, RB expression, RC expression, RD expression, RE expression, RF expression, RG expression. Okay, these all you have to write. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. ये वाला हटा दो, इतने का करके लो. ओके, कर लोगे बेटा सभी लोग? Now please tell me all things are crystal clear to all of you. Tomorrow I will discuss graphs for these complex type of reactions. What graphs they can ask in examination as well as in interviews. So many reactions I will write tomorrow, and with different values of reaction rate constant. Like in one case reaction rate constant value is like 1, in second case it is 10, in one case it is 3, in second case it is 10, in third case it is 1. So I will show you different types of graphs, standard graphs tomorrow. That is also very important, so be ready for excitement. So now for today I think that's enough. I hope everyone enjoyed today's lecture and all things are crystal clear. If the same you also feel, then please tell me in comment section beta for my motivation. Okay, so don't forget to revise notes every day. I must do my revision 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 every day. In this manner, definitely, but you are going to get rank 1, rank 100, and any rank between these two or nearby. Definitely going to make a beautiful path for your dream job. All the best, beta. Take care. Love you all, and a very happy good night to all of you. Take care. Enjoyed, sir. Enjoyed, sir. Thank you so much. You're all welcome, beta. Thank you also from my side that I got such brilliant students. Okay, beta. Take care. Ayush Kiada, Shushmit Nandi, Shiva Tarun, Mehna, Shushmit Nandi, and all. Neeraj Kumar.